All right, good afternoon. Happy Thursday. Just a reminder, you have solving by factoring and square roots due tomorrow night. Um, so hopefully things are going smoothly like that with that. Okay, today I'm going to teach lesson 3.1. But before we get started, I just want to say that there's been a couple videos on my YouTube channel that have been messed up because WebEx was making me a little thumbnail. So if you were absent recently, looking at the video, they are messed up. So I have contacted WebEx, and I think we're back on track now where you see me, in the big picture on those recordings. So hopefully, if you ever see the recordings, anyhow, we're going to do something a little different today. I'm going to put you right into the Math Wizard teams, and you're going to work a problem 3 different ways. So let me tell you what you're going to do. I want you to collaborate because I'm only going to give you less than 10 minutes to do it. So here's the problem. So here's what I want you to do. You're going to solve this 3 different ways. You're going to solve it by using a graphical approach. And what I mean by that is you are going to put x squared under y sub 1. You're going to put 16 under y sub 2. And you're going to find out the points of intersection by using the second trace feature. And you're going to find the x coordinates. The second way you're going to solve this is by factoring. So you have to know the steps. So with factoring, you have to set it equal to 0. You have to make sure it's in descending order. You have to factor and then use the 0 product property. And the third way you're going to do it is by square roots. All right. So you're going to go to your Math Wizard teams. You actually only have 8 minutes. So you're going to have to work together. And then you're going to come back to this meeting. So keep it open in your tabs. You're going to come back at 1 o'clock. So I'll see you back here in WebEx at 1 o'clock. All right, did you guys make it back?
Yep.
All right. Couple of things. First of all, I want to do this more often. I want to be able to cut out and come back and check for understanding. I need you guys, if you're having internet issues, please get a hotspot, because if there's a big alert, get a hotspot from the high school. Okay. Some of the groups finished right away. So I said to start on actually lesson 3.1 because the first couple problems are exactly like this. So I'm going to review this really quick. This is in the Explorer. Graphically is the graphical approach. So under y sub 1, you would write x squared. Under y sub 2, you would put 16. And you use second trace. So you're going to have a line going through 16. I'm not going to draw it out because I've already done this. And then you're going to have a quadratic. So just a reminder that when you hit second trace, you go to the intersect feature. You put your spider there and hit enter. He jumps to the other screen. And you find the points of intersection. So the x coordinates are going to be the answers. One of them is -4 and the other one is 4. But you have to look at each of those points and find the x coordinates. That's the graphical approach. As far as factoring goes, you have to know the steps. So with factoring, you want to set it equal to 0. Put it in standard form. Use one of the factoring methods, which is difference of squares. Use the 0 product property to solve -4, and 4. I'm just going to do square roots right here. To do this using square roots to solve it, you do not set it equal to 0. You isolate the square. You take the square root of both sides. Don't forget plus or minus. X is equal to plus or minus 4. So your solutions are -4 and 4. So those groups who did this in like 3 minutes, that's what I expect, because we've gone over this, and you should know how to do the graphical approach, and you should know how to do factoring in square roots fairly quickly. All right, so that's the first part of the lesson. All right, it's the first couple problems that you have to do. Okay, now, the first part of this lesson, like I said, is what we just did. And then you're going to have to solve specifically with square roots. So I did quite a few of those problems. Let me write this up. This is lesson 3.1. This is California Common Core Standard N-CN-1. And we are looking at solving quadratic equations by taking square roots, but they threw factoring in there because they assumed, you learned that in Algebra 1. All right, would anyone like me to work another problem solving with square roots? Last call. Solving using square roots. All right, take a look at page 115. I'm looking at the very bottom. We're going to work a couple word problems, or at least one. Okay, where it says explain two, read with me. Two commonly used quadratic models for falling objects near the Earth's surface are the following. So distance fallen in feet and time in seconds is d of t equals 16t squared. So that would go in a box because it's a fact. And then the height in feet at time t in seconds is h of t. This is distance in terms of time. This is height in terms of time. Is h sub 0, which is h is the initial height. So whenever you see v sub 0, that's initial velocity. H sub 0 is initial height. Minus 16. So that's another fact. All right, let's look at a problem. Look on page 116A. So this is on page 116A. Here are the directions. It says write and solve an equation. Now you could do this another way, but they're specifically telling you to write and solve an equation. So you must do that. To answer the given question, give the exact answer. If it's irrational, a decimal approximation in there is 1/10 of a second. So let's see, we'll do this and see how we want the answer. So here's A. If you drop a water balloon, how long does it take to fall 4 feet? Now, there is no initial height to this problem. That's why you know to use this formula. So they just want to know about this water balloon. So I recommend that you write down the formula so you can use it as a roadmap. And I'm going to read it again. If you drop a water balloon, how long? That's distance. How long does it take to fall 4 feet? Well, if this is the distance, what is the 4 the distance, or is 4 the...
You're cutting out a little bit.
Okay, is 4 the distance or the time?
The distance.
The
Right.
distance.
So you're going to put 4 in here. And look what we have. We have a problem where we can use square roots. So remember, with square roots, you can't have an x. We don't have an x. Like a single t. So we can use square roots on this, but I'm going to simplify first. So I'm going to divide both sides by 4. So I get 1 is equal to 4t squared. And I'm just going to write it like this because I like my variable on the left. So now with square root method, you isolate the square. And you take the square root of both sides and don't get plus or minus. So you get t is equal to plus or minus. The square root of 1/4 is 1/2, isn't it? 1/2 times 1/2, a 1/2 comes out. So we have 2 answers. We have t is equal to negative 1/2, and we have t is equal to positive 1/2. And in regards to time, time cannot be negative. So we have one answer, and the answer is, how long does it take the water balloon to fall? 4 feet? It takes the balloon
half a second.
Yeah, a half a second to fall 4 feet. So see how I'm writing the answer to the question? So the question is, how long does it take the balloon to fall 4 feet? It takes the balloon a half a second to fall 4 feet. So pretty easy now that we know how to use, how to solve using square roots. Okay, let's look at B on page 116. Listen to this problem. The rooftop of a 5-story building building is 50 feet above the ground. How long does it take the water balloon drop from the rooftop to pass by a 3rd-story window that's 24 feet? So it's like, wow, that doesn't sound like a simple problem. You know, that sounds like this problem. And I think it is. So let's take a look at this. So in this case, the question is, how long does it take? So once again, we want time. But the question is, what's going on here? What would be our initial height? Wouldn't our initial height be 50? And doesn't it make sense that it's 50 minus 16t squared? And wouldn't our final height be 24? So see how in this formula we need 2 parts? There's 3 parts, but we need 2 out of the 3. So they gave us the initial height of 50 and the 24. Let me read it again. The rooftop of a 5-story building is 50 feet above the ground. How long does it take the water balloon drop from the rooftop to pass by a 24-foot height? 24 feet. So wouldn't 24 be h? And isn't 50 the initial height? So we're still going to use square root method, but look at, I can divide everything by 2, can't I?
Yes.
So I'm going to divide.
Question.
Are you going to ask the question or?
Yeah, sorry, it lagged. So aren't they trying to say how long it would take to get to the 3rd-story building? But it's not taking 4 feet to get to that floor. Wouldn't it be 26? Because it's only dropping 26 feet if the 3rd floor is above 24 feet. Because it's not going from the ground up. That's where I'm.
Yeah. Okay, let's make sure we understand the problem. It says that the building, it's 5 stories and it's 50 feet above the ground. So we know that the building is 50 feet. Okay. How long does it take the balloon drop from the roof to pass that height?
So wouldn't it be 26?
No. How long does it take the water balloon drop from the roof to pass by a 3rd-story window that's 24 feet?
Okay, maybe I'm just thinking too hard about it.
Well, hold on. This problem can actually be done what you're thinking about is the 26 could actually be used in the other problem, in the other formula. But anyhow, let's just do this and then we can go back to that. But the 26 could actually be used in this formula. Anyhow, divide by 2. Divide by 2. What would that be, 25? Divide by 2. And now we're going to isolate the square. So you would subtract 25 from both sides. So you get negative 13 is equal to negative 8t squared. And I don't like all those negatives. So I'm going to multiply by a negative 1. Now I'm going to divide both sides by 8. And now I'm going to take the square root of both sides. Can't have a fraction under a radical, so it'd be radical 13 over radical 8. Can't have perfect squares under there. So it's going to be radical 13 divided by 2, radical 2. Have to rationalize the denominator. T is equal to plus or minus radical 26 divided by 4. So there's 2 answers here. There's negative square root of 26 divided by 4 and positive square root of 26 divided by 4, but the negative time doesn't make sense. And by the way, that doesn't make sense to a human being. And so we would want to change this to a decimal. So since this is a real life problem, humans are not going to understand that. So what you're going to want to say is you're going to want to say that the water balloon passed by the 24-foot or you could say the third story. Be easier to just write third story. The third story. And you're going to want to get a calculator and figure out that approximation. So as a math teacher, this is the answer I want to see. But as a human being, what is square root of 26 divided by 4? Somebody, I'm not going to do it. What's square root of 26 to what?
1.27.
So it's about 1.3 seconds. So that's what you would write in your statement. The water balloon passed by the third story in approximately 1.3 seconds. So as a math teacher, I want the exact answer. As a human being, if you're working for somebody, you're going to want to convert it to a decimal because 1.3 seconds makes more sense to a human. All right, so basically, if you have a simple problem, you're using the first formula. If you have a problem that involves an initial height and another height, you're going to be using the second formula. And you can't expect one of these on the exam. So there might be one of these on the exam. All right, does anybody want to ask me any questions about it?
I'm Miss Bridge. So the formula has like the 16. So it's always going to have the 16 in the formula?
Yes, this is a formula. Yes, this is a formula.
Thank you.
This is a fact. Yep.
Miss Birch, which H is the initial one?
Whenever you have like even in physics, chemistry, or biology, whenever you have a sub-zero, that's like V sub-zero is initial velocity. H sub-zero is initial height. And initial means starting height, right?
Okay, thank you.
Yep. So now you see why I wanted to go through square root method and everything, because now it's in the mix of, you know, it's part of a problem. It's not the problem, you know, so we don't want to be struggling with factoring and square roots. We want to be able to just, you know, work them when we see them, because they're going to always show up in problems. Okay, can you look with me on page 117? We're going to look at imaginary numbers. Somebody asked me one time, you know, it's like, when are we ever going to use imaginary numbers? And you use them with electric circuits. So when you look at resistors and inductors and capacitors, you do deal with imaginary numbers. All right, so let me just talk about the imaginary numbers. First of all, before I start this, okay, so all the numbers you've ever heard about are real numbers. So all the real numbers you know about natural numbers in kindergarten. You learned about whole numbers, which include the natural and the number 0. In algebra, you learned about integers. You also learned about rational numbers. Those are numbers that can be written as a fraction. And then irrational are all those nasty decimals that are non-terminating, non-repeating. Now, there is another number set called the imaginary numbers. And together, these two make up a complex number system. And a complex number looks like a plus bi. Now, a is called the real part. B is called the imaginary part. And I is the imaginary unit. Now I'm going to explain all that in depth, but not right now. All right, so the imaginary numbers, what do they look like? Well, they could look like 2 plus 7i. They could look like -5 plus I. -1 minus 5i. And then there's a subset of these called pure imaginary. And these guys don't have a real part. So the pure imaginaries look like 5i, 2i, I, -7i. So sometimes they'll give you a problem and they'll ask for the real part, the imaginary part, so what would be the real part here? Go ahead. What would be the real part?
Would it be 2?
2.
Yeah. What would be the imaginary part?
7i.
It's actually -7 because I is the imaginary unit. Okay. So let's do another one. Let's say you had 4 plus I. What would be the real part?
4.
4?
Right. What would be the imaginary part?
1?
1.
Right. Okay, so it gets a little bit trickier. 5. What would be the real part?
Would it be 5?
What would be the imaginary part?
Would it still be 5?
Nope.
There is no imaginary part.
There is. Wouldn't it be plus 0i. So wouldn't the imaginary part be 0?
Oh, that makes sense.
Okay, so what about this one? What's the real part?
Zero.
Right. Because we can write that as 0 plus 2i, right? So what would be the imaginary part?
2.
So in the complex number system, we would consider this a complex number. Consider this a complex number. This guy, he's complex, but we consider him a complex real number. And over there, we consider that guy complex because they're all complex because complex is the umbrella. This guy would be complex 1. Pure imaginary, right? Complex pure imaginary. Is okay?
Yep.
Oh yeah, just the camera. Thank you.
So your whole life, you only knew this. And now what we've done is we have made another number system called the imaginaries, and they fit under this umbrella called the complex number system. All right, so what's going to happen here is, well, let's talk about the imaginary unit. So I is the imaginary unit. And does anybody know what he's equal to? He's equal to the square root of -1. And I squared is going to be equal to -1. Because when you, I times I is I squared, and I squared is going to be -1. So those are facts. So they're going to give you some problems like this, and they're going to say, find the square. Now they're not saying square root, they're saying find the square. So this is actually in your assignment. What kind of number is this? Is this number real? Is it complex real or complex imaginary or complex pure imaginary?
Complex pure.
Complex pure imaginary.
Yep. And so if they ask us to square this, wouldn't this be 25i squared? Yes, no.
Yes.
Yes.
Well, isn't I squared equal to -1? So shouldn't we take it out and put a -1 in? So isn't this answer really -25? So I is a number. It's square root of -1, but we treat it like a variable. So like we treat it like a variable, but you have to remember that if you ever have an I squared, see, teachers used to tell me, don't use I in algebra. Don't use I in algebra because it looks like a 1. That's not the reason. You don't use I because it's a number. So what you always need to do is whenever you see an I squared, you have to take it out and substitute in a -1. Let's do another one. How about if they want you to square that, wouldn't that be this? And wouldn't you have to square the -1, the I, and the square root of 2? Aren't there 3 parts to square? So what would you get? What's a -1 times a -1?
A positive one, and then wouldn't it be 2?
Wait a minute. A negative times a negative is a positive 1. And then we would have an
Yeah.
I squared and a 2. So we would actually put it out in front. 2I squared. Right? Yes, no.
Yeah.
So now this would be 2 times -1, which is -2. All right, would you like me to work more of these?
Yes, please.
Hey, how about this one? That's pure imaginary. If they want us to square it, wouldn't you have to square all 3 parts? So what would you get? What's square root of 3 times square root of 3?
3.
What's 3 times 3?
9.
I squared. Well, we're not done. We would have to simplify the fraction, which would be 1/3. And wouldn't that be times -1? So wouldn't this answer be -1/3? It's like 4 steps. Do one more. If they want you to square that, don't you have to square the -1, the 2, and the I? So what would you get?
-4.
Hold on, isn't a -1 times a -1 a positive 1? Isn't this -1 times 2 times I quantity squared? Yes or no?
Yes.
Yes. So would it just be positive 2?
A -1 squared is 1. 2 squared is 4. I squared is I squared. Are you guys with me or no? Do you understand what's going on when we square or no?
Yeah.
So you understand
I'm so
this. This is -1 times 2 times I quantity squared.
Wait, so Miss Birch, we're basically breaking up the -2i into like 3 different parts?
Yeah,
Okay.
but you never see people write this, but I'm just doing it for you. This is -1 times 2 times I quantity squared. So a quantity squared is 1. 2 squared is 4. And I squared has to be changed to a -1, right? So the answer is -4. So this is a 4-step problem. What I'm saying or no?
Yeah, I
Yes.
get it.
You get it? Okay. Does anybody not understand and you want to ask me?
One question, how do you know if it's complex, pure, or real pure? I think I missed that.
Okay, there is no real pure. When you have a complex number that doesn't have a real part, it's pure imaginary. It's complex, pure imaginary. This is pure imaginary.
So if it was like 2 plus I, then that wouldn't be pure?
That's just no, that's not pure. That's just complex because it has a real part. When it has a real part and imaginary part, it's just a complex number.
All right, thank you. I got it.
Okay, so this is complex. When it has just a real part, it's complex real. And when it has just an imaginary part, it's complex, like pure imaginary. And sometimes, when they're just complex like this, we just call them imaginary. That's not pure imaginary. That's complex. But sometimes we just call it just imaginary because it has an imaginary unit in it. All right, you guys ready to solve with imaginaries? So check this out. So we're going to solve. Solve means find the solutions. And solve means find out where it's crossing the x-axis. So as soon as you see this,
Ms. Birch,
you're
can
going to
you count,
say,
please? Thank you.
you're going to say you can't factor that. So let's use square root method. So remember, square root method, you can't have an x, and we don't. So what are the steps? Isolate the square. Take the square root of both sides. Don't forget plus or minus. Now look at this. There's a negative under the radical. So there are no real solutions, but there are imaginary ones. And by the way, so a negative under a radical, that means imaginary. Now, only square roots. Cube roots, it's real, but a negative under a square root means imaginary. And the imaginary solution come in pairs. So imaginary solutions come in pairs. So that means if 5 plus I is a solution, 5 minus I is a solution. If 2 minus 3i is a solution, it means 2 plus 3i is a solution. They come in pairs. So the first thing you're going to want to do is when you see that negative, take the I and take them out. Because let me just show you what this means. Doesn't this mean square root of -1 times square root of 12? And isn't square root of 1 I? So isn't 12 2 times 2 times 3? So wouldn't our answers be plus or minus 2 radical 3i? Now, these cannot be graphed in the Cartesian coordinate plane. The Cartesian coordinate plane is a real plane. You're not going to be asked to graph these, but you cannot, there is a complex plane. And in the complex plane, the x-axis is the real axis, and the y-axis is the imaginary axis. We're not going to get into that. So there is a complex plane. Don't worry about graphing those. Just know that these cannot be graphed in the Cartesian coordinate plane. Let's do another problem. Four x squared plus 11 equals 6. They want you to solve it. So you notice if you set this equal to 0, we're not going to be able to factor it. So we're going to use square root method. So we're going to isolate the square. We're going to isolate the square. And we're going to take the square root, make sure you bring it all the way down, of both sides. Don't forget plus or minus. So first of all, you see that negative under the radical? You could write this step, but we're just going to say, hey, we have a -1 under there. So that's going to be I. We're going to split up the radical to square root of 5 over square root of 4. And so what do we have here? We have x is equal to plus or minus square root of 5 over 2i. So your solutions are negative radical 5 over 2i and positive radical 5 over 2i. So remember, the imaginaries come in pairs. Okay, so let's try one in our teams. So we're going to go back to the Math Wizard teams. I'm going to give you a problem, and you're going to come back to me at 2:05. Okay, here's your problem. So what you're going to do is you're going to solve this using square roots. If you end up with under the square root, you can take an I out, because that means you have a square root of -1 under there. All right, so I'll see you back at 2:05, and you're going to solve this one collaboratively. Make sure you talk out loud and solve it as quickly as possible. All right. Okay. Hi, guys. Are you back?
Yes, we are.
Yep.
Okay. So let's talk about this. You end up with a -5 on the bottom. So move the negative up. So you take the square root of both sides, and don't forget to put plus or minus. So the first thing you do is, since you have a negative under square root, take out an I. So you have plus or minus radical 7 over radical 5i. Well, no, you can't have a radical in the denominator. Remember we went through all those problems? So you have to rationalize the denominator. That's why we did all those problems. So you get x is equal to plus or minus square root of 35 over 5i. That is simplified because there's no perfect squares into the radical, there's no radicals in the denominator, and there's no fractions under the denominator. So, no fractions under the radicals. So your answer is negative square root of 35 over 5i and positive radical 35 over 5. So that's why we went through all of those sheets of simplifying radicals, because now they're just assuming you know how to simplify a radical. So you can't have any negatives under the radical now. You have to pull the I out. Can't have any fractions under the radical. Split it up. After you split it up, you can't have a radical denominator, and you have to rationalize the denominator. So that's why I wanted to go through simplifying radicals, because it's part of a bigger piece.
So the negatives on the denominator, we move it to the top?
Well, watch. If you have 7 over negative 5, what's equivalent to this is negative 7/5. And what's equivalent to that is negative 7/5. So these are all equal. So we do not like that. So move it up. It's all equal, negative 7/5, negative 7/5, negative 7/5.
Yes.
Okay. All right, now pay attention to the deadlines. So tonight is solving by factor roots. You should be done with that though. Like you should just be turning it in tomorrow. You're not waiting till the last minute. Some people are saying, why are the teachers giving 11:59 as the assignment due date? That's because we're just giving you extra time. We're not wanting you to wait to turn it in then. Turn it in the day before. Turn it in the morning. Okay, and this is going to be due on Tuesday. So, got to stay on top of things. You should be starting on this right away. This is due on Tuesday at 11:59. All right, that's it for today. I hope you guys have a great day. If you want to hang out and ask me questions about this, you can. I'm going to turn off the recorder though, and I hope you guys have a great day. Good job today.